How's everybody doing? Well, we're here to talk about simplifying algebraic expressions. Now, we've done a lot with simplifying using our order of operations, but with those, we always had known values. We had numbers that we could actually add, subtract, multiply, divide, use exponents, absolute value, all that good stuff. What happens, though, when we start putting variables into our expressions? And that's what we're going to talk about today. How do we simplify this? Well, first question we have to ask ourselves is how many operations do we actually see are there in this expression? Now, some of you might have said 2, but there is actually 4. There's 2 multiplications in between the 8x and the 9y, a subtraction and addition. And this brings us to what we call our multiplication ninja, right? We talked about how we are going to have a lot of ninjas in math, and this is our ninja operation, right? Multiplication is the only operation which does not need to have a symbol in the expression for you to be expected to know it's there, right? But the question is, can we actually perform this multiplication? Can I actually multiply 8 times x and come out with a simplified value? And the answer is no, because x and y, while they are actual numbers, they are unknown numbers. We don't know what they are. I can't multiply something known by something unknown, right? So we can't do that. Well, what about the addition and subtraction? Again, we come into a problem here. I can't add the 9y and the 10 because the 10 is known and the 9y is a term where it has an unknown. I also can't subtract the 8x and the 9y because x and y are different unknowns. I don't know what they are. So the question then begs, how do we ever perform any operations if our expressions have variables? And for this, we have to learn an important vocabulary word that we are going to carry with us throughout the rest of the year. And that vocabulary word is like terms there. Now, that seal sure looks a lot like Kevin there from The Office, but we need to be even more precise in what we consider like terms. Like terms are terms with exactly the same variables and with exactly the same exponents. So the terms have to have the same exact variables, and those variables have to have the same exact exponents to be considered like terms. And if they are like terms, we can then combine them with addition or subtraction, which we'll see a number of examples of coming up here. One important thing to remember here is that coefficients have nothing, big capital letters there, right? For you texters, that means important, pay attention. Nothing to do with terms being like terms. It's all about the variables and the exponents when we are deciding if terms are like terms, right? So now that we've defined it, let's look at several examples here. We've got 3 lists of terms. Now, these aren't written as expressions. Notice we're not adding or subtracting yet. We just want to work on identifying which terms are like terms here. So we can see in our first list, I've got 7x, negative 3y, 6x squared, and 12y. Which terms there do you think would be considered like terms? Well, hopefully you said negative 3y and 12y. Notice they both have the same variable, and as far as we can tell, neither variable has an exponent there. So they have the same variables and the same exponents. 7x and 6x squared are not like terms because even though they have the same variable, those variables have different exponents. Let's take a look at the second list here. We've got a number of these. Which of these terms, I'll give you a minute to think, a second or two to think about it, which of these terms do you think are like terms? Hopefully, you notice there's actually 2 different pairs of like terms. The 3a to the 4th b and 7a to the 4th b are like terms. Same exact variables with the same exact exponents. And then 3b and negative 3b are like terms because they have the same exact variable with the same exact exponents. Even though 9a has the same variable as the 3a to the 4th b, it is not a like term with that because it doesn't have all the same variables with the same exponents. It's got to be exactly the same. The seal and Kevin, not close enough. Let's try, how about you try the last one on your own here. So pause the video, take a look at it, and let's see what you think. Ready? Pause. Hopefully, you noticed that the m to the 3rd p squared terms were our only like terms. Even though every term has the same variables, there's only 2 terms where those variables have the same exact exponents. So Hopefully we're feeling a little bit better about like terms. So let's actually now apply what we know to simplifying our expression. We said earlier that we can simplify, we can add or subtract the terms, combine those terms if they're like terms. So if you look at A, which terms there would be like terms that we could actually combine? Well, we can see that the 6x and the negative 3x are like terms. So I add those two, 6 plus negative 3 gives me 3x. The 9b and the 5b are also like terms, so I can add those and get 14b. Now that's as far as I can simplify, because the 3x and the 14b are not like terms, and I can't multiply a known by an unknown, so that's as much as I can do, and that would be considered fully simplified. Let's look at the second one here. Now, we can see a lot of y's here, but there's only two like terms, the 7y squared and the 6y squared. We can combine. Notice I don't combine the 6y and the 6y squared just because their coefficients are the same. That doesn't matter. And the variables do not have the same exponents, so we do not combine them. The negative 4 is a constant with no variables, so I can't combine that with terms that have variables. Those aren't the same variables. Let's take a look at our last example here. So we've got a bunch of m's and n's down here, and, it's kind of a trick question here. We can't simplify, this is already fully simplified, we can't simplify it anymore. None of the terms are like terms. Even though some of them have the same variables, the variables that are the same do not have the same exponents. So we would just say this expression is already fully simplified. Well, we've learned about like terms, we've learned how to combine terms that are like terms, so why don't you try some on your own? We've got 3 examples here. We want you to show your work, show which terms are like terms, and then combine them to simplify the expression. Ready, pause. Well, let's see how you did. Hopefully you got negative 2h squared plus 12h plus 5b, 9ab minus 7a plus 4b plus 8, and 3p squared minus 2p plus 11. If you have any questions about these, again, guys, we're going to say this pretty much every single video, so that either you'll ask questions because you want to know the answer, or you'll just ask questions to get us to stop saying it over and over again. If you've got questions, if you did not get the same answers we have above, please make a note in your notes so that you can come to class and ask questions about this, and we can talk about it tomorrow. Well, that brings us to the end, and this is where Porky Pig would crash through the screen and tell us that's all, folks. And if you have no idea who Porky Pig is, shame on you.